Alright, hello, this is 7.5 exponential and logarithmic equations. We're going to solve exponential and logarithmic equations. That's our main objective for today. Okay, so the first thing we want to look at is we want to talk about exponential functions. And there's actually some tips here that I want y'all to keep in mind. We want to try writing both sides, having the same base. I kind of messed up there, but that should be having the same base, or to have the same base. So let's say here, to have the same base. And also keep in mind that you can take the logarithm of both sides because that can help kill the exponent, or the exponential function. Okay, so for example, let's look at this first example. 8 to the x power is equal to 2 to the x plus 6 power. Now you have to realize that 8 is a power of 2. That means 2 raised to, like 2 times 2 times 2 got me an answer of 8. So you might want to generate a table with some basic powers like 2, 2 squared, 2 cubed, 2 to the 4th, 2 to the 5th, 2 to the 6th, maybe 3, 3 squared, 3 cubed, 3 fourths, 3 to the 5th, 4, 4 squared, 4, with the first, let's say 5, 6, 7 numbers, okay, and go to at least the 4th power. That would help you for your test. So keep in mind 8 is 2 to the 3rd power. So I rewrote that as 2 to the 3rd raised to the x. 3 times x gave me 3x. And then I have 2 to the x plus 6. Now, since these are the same base, I can cross them out and just set them equal to each other. So it'd be 3x is equal to x plus 6. And then you can subtract the x's and get 2x equals 6, divide by 2, and you get x equals 3. So keep in mind that, again, the idea here is if you can get them into the same base, in this case 2's, you can cross out the bases and set the exponents equal to each other. If you can't, then you have to do logarithms. So let's look at the next example. 5 to the x minus 2 is equal to 200. Okay, you could check, again it would be a lot easier if you already had this on a table on your own paper. There is no power of 5 that will get you to 200. Because it's 5 times 5 is 25, times 5 is 125, times 5 is 625. Okay, so in that case you do logarithms. So you take the log of both of them. When you do that, keep in mind there is a property that says the exponent on a log can go to the front. So I'm going to say here x minus 2 times log 5 equals log 200. Now that means that these are equal, or these are actually numbers. These logs are actually numbers. So I can treat them like numbers. So I've got multiplication. How do I get her to multiply? You divide. So I now have x minus 2 is equal to log 200 divided by log 5. And then I could add 2 to both sides, and I could actually just type that into the calculator. Now keep in mind, you need to make sure that when you type that in, you're typing that in as log 200 divided by log 5. Like control divide to get your division and type in log on both top and bottom. Don't try to combine it and say log of 200 divided by 5. It is the way it's written, log 200 divided by log 5 plus 2, and you should get an answer of roughly 5.29. Okay, so next example, same thing. Okay, again, you should know that 27 is a power of 3. It's actually 3 to the 3rd power. And now that they're the same, I can drop the 3's and say 2x is equal to 3, divide by 2, and I get x equal to 3 halves. Another example. And again, you could do these and stop once you've once you've done it, stop to see what you got. Okay, so here I've got, there is no power of 27 that will give me 21. So I'm just going to write here log 7 to negative x is equal to log of 21. Move the negative x to the front, and then I can treat that log 7 as a number and divide. So I can say negative x is equal to log 21 divided by log 7. Divide by negative or multiply by negative, change the signs, whatever you want to think of it like. And then type it into the calculator and get your answer of negative 1.56. Okay, so that's exponential functions. Or equations, I'm sorry, in a nutshell. So let's now look at some logarithmic equations. And here are the tips I have for those. If you can, you try to make single logs on each side. And if when you have log A is equal to log B, then you can just drop the logs and say A equals B and solve. But keep in mind, a lot of this deals with the exponents, and logs cancel each other out. So keep that in mind, that when you have, like, say, a base, log in a certain base, an exponent, make that into an exponent and they will cancel each other out. For example, here I have log 3 of x, or log base 3 of x minus 5 is equal to 2. Okay, this is already a single log. They're not logs on both sides, so the easiest thing to do is to raise them both to the power of 3, because that was the base. Because the base is there, I'm making that. So now this is all of this right here is an exponent. Okay, all of that has become an exponent, and I'm saying equals 3 to the second power. With that being the case, I can cancel out those log and the 3, leaving me x minus 5 equals 9. Then I can add 5, and 9 plus 5 is 14. So the idea is that these are not very hard. You just got to make sure that you, say, raise them to the exponent, but get them down to single logs first. Okay, let's look at another example. Log 45x minus log 3 equals 1. Okay, to rewrite as a single, remember, minus means divide. So I'm going to say 45x divided by 3 equals 1. Well, 45 divided by 3 is 15. So I have log 15x equals 1. Now, what base is this in? Again, if I don't see a base, it is in base 10. So if I raise these to the power of 10, then I can cancel out the log, be left with 15x equals 10 to the first power is 10. Divide by 15 and you'll get 2/3. Okay, my final example, log base 4 of x squared is equal to 7. Again, when I see an exponent there, I can move it to the front. So I'm saying 2 log base 4 of x is equal to 7. You need to isolate the log, so I need to get rid of this times 2. So I'm going to divide by 2. So now I'm saying log base 4 of x is equal to 7 halves. Okay, and then I can do the exponent, make them into exponents, so that I would cancel out the 4, the log and the 4, and leave me with x. And then I can type into the calculator 4 raised to the 7/2 power, which is 128. There is some others that might have you do something with, say, factoring or, say, quadratic formula, but this is the main gist of it. There should be no real difficulties, and if you do have any questions, feel free to ask. Thank you very much.